Hi everyone, my name is Aaron and I'm going to talk to you today about integrating Windows Virtual Desktop with Microsoft Endpoint Manager, and in particular securing WVD with Endpoint Manager. I've got a number of topics I'm going to cover. I'm going to start with my reasoning why I believe that Windows Virtual Desktop and Endpoint Manager are a good fit. I've got 3 topics from a security perspective that I want to cover and how to utilize Endpoint Manager to secure WVD. And then finally, I've got a bonus round. I've got a bit of a demo that I'm going to show at the end of the video, so stick around to the end. First off, though, I want to start with a bit of a stat. So here's a statistic from the IBM cost of a data breach that came out last year, after COVID, in fact. And one of the questions that they asked respondents was, could a pandemic increase the cost of a data breach? And the answer to that question was overwhelmingly yes. Organizations towards the beginning of last year had to do a mad scramble to enable users to work remotely as the pandemic hit. A lot of organizations, in particular customers that I've spoken to here locally, were in a situation where they just weren't ready for remote work, or they were doing things like picking up physical PCs and taking them home and then finding that they had no way to manage those devices, to deploy applications, deploy updates and so on. So a lot of organizations were caught in a scenario where they just didn't have the right tools in place to support remote work. So if there was a data breach in that scenario, they would certainly be in a situation where they just would not be prepared for it. So that would of course increase complexity and increase the cost of recovering from a data breach. The second stat here is from Accenture. This one's kind of interesting, that the average cost of a malware attack is rather high. And to be honest, we saw this with a customer who, for obvious reasons I won't name, but about 12 months ago, just about this time last year, they went through a scenario where malware was introduced in the environment and basically brought the IT organization to its knees. And we've been working with them for more than the past 12 months, I would say, in recovering from that scenario. So it has costed them quite a significant amount of money, pain, and effort to actually bring that their services back to 100%. Clearly, organizations have concerns, real concerns, where have a malware or have a data breach incident, potentially that can bring the IT organization to its knees and affect the business. Employees will be unproductive. And the concerns are the same regardless of whether it's physical or virtual. From an IT perspective, we need to make sure that those devices or those virtual desktops are secure. And of course, I guess Microsoft Endpoint Manager is a great tool to actually be able to do that. So let's ask a simple question. What is Windows Virtual Desktop? I think there's a simple answer to this. It's a Windows desktop. So it's Windows Virtual Desktop, while it might be a virtual machine sitting inside Azure, and I'm leveraging all the benefits that Azure gives me to be able to design and build a virtual data center to host WVD. At the end of the day, users are still logging into a Windows desktop that they need to access their applications and data from. So I still have the same concerns, the same requirements and expectations on me to secure virtual desktops as I do physical PCs. So there's obviously crossover between Windows Virtual Desktop and Microsoft Endpoint Manager. So from a licensing point of view, quick recap. To license Windows Virtual Desktop, we need licenses like Microsoft 365 E3, E5. These same licenses give us access to Configuration Manager as well as Intune, so Microsoft Endpoint Manager. And again, coming back to say the Microsoft 365 E3, E5 licensing, these allow me to use both Windows Virtual Desktop, Configuration Manager and Intune, and I can manage physical devices, Windows 10 PCs, maybe I can manage Macs, iOS and Android, but I can use those same entitlements to go and manage Windows Virtual Desktop. As I said before, at the end of the day, Windows WVD is still a Windows desktop. So putting these two together, the crossover here is, for most customers, is going to be the Microsoft 365 E3, E5, F3 licenses. Okay, so why Configuration Manager and Intune together? Why Microsoft Endpoint Manager? Well, let's take a quick look at a few things. First of all, let's have a look at the Endpoint Manager architecture. So what I'm doing with Endpoint Manager is I'm leveraging Configuration Manager. A lot of organizations I've spoken to in the past are definitely using Configuration Manager to manage their VDI environments as well as physical PCs. But now they can take that a step further and integrate both Configuration Manager and Intune together to get a whole lot of other features that are useful for both virtual desktops and physical desktops. So I'm leveraging Config Manager to manage Windows PCs. They might be hybrid Azure AD join machines that I'm using today, so on physical desktops. They may also be hybrid Azure AD joined virtual desktops, and it's certainly something I'd be doing with Windows Virtual Desktop. And I can use Config Manager to do patch management, application deployment, software inventory, reporting, and so on. And if I extend that into Intune or up into Azure, I get a number of benefits. Not only can I manage Windows PCs, of course, I can manage macOS, iOS, and Android through the same console. And then I can get a sort of a one-size-fits-all for my device management requirements. So what are the actual benefits? Why would I go a step further and integrate Config Manager with Intune or extend Config Manager up into Azure and into the Microsoft Endpoint Admin Center? So the first of those is co-management and tenant attach. I like this. I think is a great feature because I can use Endpoint Manager, or the Endpoint Manager Admin Center as a method for Service Desk to get access to Windows desktops. So I might have Configuration Manager admins, and I may have Service Desk, level 1, 2, or 3, whatever that might look like. And I don't have to give them access to the Config Manager console. I can instead direct them to Endpoint Manager Admin Center if I'm actually enabling co-management and tenant attach. So here I've got my list of devices. And in particular, say Windows devices that are listed in my tenant. So here I've got a mix of Windows Virtual Desktop VMs, I've got a mix of physical PCs, and I've got sort of fixed desktops and laptops, and I'm provisioning either through hybrid Azure AD joined devices or Azure AD joined devices using Windows Autopilot. Of course, I can't use Autopilot with WVD because it's sitting inside Azure, but I can expose that into the Endpoint Manager Admin Center. So here is one of my Windows virtual desktops, and from an administrator point of view, I can look at everything that's being pushed to that application, to the VM. So maybe I'm reporting on applications, or I'm reporting on policies and compliance status on that virtual desktop. And I can even do things like reporting on Defender integration and so on. So all the power that I get out of Config Manager, I can bring up into the Endpoint Manager Admin Center. I can manage both physical and virtual desktops in the same console. And it also gives me that separation between, say, the VDI administrator or the Configuration Manager administrator and Service Desk who need to just look at devices from a Service Desk perspective inside the Endpoint Manager Admin Center. Secondly, desktop analytics. So this is a powerful tool which everyone I think should be using to manage Windows as a service. So a lot of organizations have been managing Windows as a service on physical PCs for a long time. I don't see any reason why you shouldn't be doing exactly the same approach for Windows virtual desktops. At the end of the day, they are Windows desktops, and I'm deploying a specific version of Windows today. 6 months down the track, a new version of Windows comes out, and I want to update those devices, or those virtual machines, to the next version of Windows. So desktop analytics requires Configuration Manager. I can't do desktop analytics with just Intune alone. But what it gives me is deep insights into what's going on inside those virtual machines. So let's say applications, as you can see here. What is the status of those applications, and are they going to be compatible with the next version of Windows? On physical PCs, I can also look at things like device drivers and so on, and integrate those into my compatibility plans. But basically what I can do with desktop analytics is plan application compatibility, ensure application compatibility issues have been resolved, and plan that upgrade to the next version of Windows 10. Thirdly, and I think this is a key one, which I can delve into. I can sync config manager, device collections, and even user collections into Azure AD groups. So Azure Active Directory groups are great. I can use them to assign resources such as applications or policies to Windows machines, whether that be WVD or a physical device. However, Azure AD groups, they're fairly limited in the query capabilities that you can utilize in them, where if I can take what I get out of Config Manager, which is far more flexibility in the types of analytics and properties on a particular device that I can use in my device collection queries, I can then query those inside Config Manager and synchronize that up into an Azure AD group. So that would look a little bit like this. I've got a Windows 10/Enterprise collection. Mind you, this is pretty simple. All I'm doing really is just querying, is the device running Windows 10 Enterprise or Pro? And I'm synchronizing that device collection up into an Azure AD group. So if I'm using Configuration Manager today and I've got a number of device collections, I might be using advanced queries. Let's say, for example, I'm looking at for the existence of a piece of software on a device or particular types of hardware, or in the case of Windows Virtual Desktop, maybe I want to make a distinction between Windows 10 single session, Windows 10 multi-session, or even different host pools. I could be able to query that with the Config Manager collection, synchronize that up into an Azure AD group. And those types of queries I can't necessarily do with an Azure AD dynamic device group by itself. Finally, there's application control. So I'm going to jump into this in a little bit, but Configuration Manager makes the implementation of Microsoft Defender application control a bit simpler. So let's take a little bit of a look at what's in my environment. So I'm doing a couple of demos out of here talking about integration with Endpoint Manager and WVD. And in my lab here, I've got a machine that I'm running a number of virtual machines on-prem. I've got Active Directory running here. I've got a Configuration Manager primary site server. I've enabled co-management and I've enabled tenant attach. And I'm deploying Windows Virtual Desktop into an Azure region. Up in that region, I've got a couple of networks. I've got a hub network and then a spoke network where I'm actually storing or running my virtual machines. And those machines can talk to Active Directory over a VPN connection. And I'm using that to allow those virtual machines to talk back to the Configuration Manager via the Config Manager agent, but also then register with Intune so that those machines can be managed either with Config Manager or Intune, depending on what my requirements might be. So this then leads to what I think is a great question. Should I manage Windows Virtual Desktop with just Configuration Manager or Intune? One of the conversations I had with a customer not so long ago is that they're looking at a move from on-prem VDI to Windows Virtual Desktop. And what they're looking to do in their strategy is reduce their on-premises services. So the idea is if they can go to Windows Virtual Desktop, removes the need to manage VDI on premises. What about device management for Windows Virtual Desktop VMs as well? Why not just leverage Intune as well? Well, I think I've just shown previously that there's a number of features where Configuration Manager adds value to Intune. So you're leveraging Intune and Configuration Manager together to get additional features. The question perhaps is going to depend on Windows 10 single session or multi-session desktops. So a Windows 10 single session desktop can support enrollment into Intune just like a physical PC, and management is going to be very much the same. So a user logging onto Windows 10 single session desktop is going to access the same type of Win32 applications, and a single session desktop I still think works quite well for store-based applications. Think about Microsoft 365 customers and the Microsoft To-Do application. So it's a great application for managing a to-do list, but it's only available as a store-based application. So I can definitely use that on Windows 10 single session desktop. Windows 10 multi-session is a little bit different. So Microsoft announced support for enrollment into Intune with Windows 10 multi-session not so long ago. So this is actually still in preview at the moment. And when you enroll Windows 10 multi-session desktop into Intune, it supports only device-level policies, which makes sense from a multi-session operating system because multiple users are going to log on to the same virtual machine. They're going to get a consistent or the same type of desktop experience and pretty much the same applications across the board. So I just need to manage the device-level configuration applications on that device. However, given that it's a multi-session operating system, I think sometimes you might need the extra flexibility of managing applications and policies and so on through the Configuration Manager agent. So whether you use Config Manager by itself, Intune by itself to manage your Windows Virtual Desktop environment, or both of them together, I think you're going to have to go and have a look at your application requirements, look at your policy requirements, and look at the types of host pools that you're deploying. Are you deploying just Windows 10 single session, or are you deploying Windows 10 multi-session as well? So if I go have a look at this with integrating Config Manager and Intune, I can now start to move some of the workloads over from Config Manager over to Intune. Most organizations from wanting to manage physical PCs, so last year with this rush to support remote work, a lot of organizations were caught with the inability to manage remote workstations. And they've been adopting Cloud Management Gateway inside Configuration Manager so they can manage those devices. But they've also got the choice with co-management to move some workloads over to Intune. And where that makes sense may potentially be things like applications and Windows Update policies. So think about physical PCs. I want to deliver applications to those devices that are out on the internet, and I'm delivering maybe applications and Windows updates up through Config Manager, Cloud Management Gateway, and then out to those devices that are out on the internet. If I can move a lot of those workloads over to Intune, then it's going to simplify delivery of those components because I'm not having to drive them through Config Manager and potentially pay for the bandwidth. If I can move them to Intune, then I can leverage Microsoft to deliver those bits instead, and I just use Cloud Management Gateway to manage policies and so on to my managed endpoints. However, with Windows Virtual Desktop, WVD is already sitting up inside Azure, so Cloud Management Gateway may not necessarily need to be in play to manage Windows Virtual Desktop. A WVD desktop is still joined to Active Directory, still has direct connection to a Config Manager distribution point, so I could still continue to push out applications and updates from Config Manager. But if I do move these types of workloads, and in particular I think Windows Update policies over to Intune, then I far simplify Windows updates, not only just operating system quality updates, but also feature updates. In-place upgrades to the next version of Windows are far simpler with Windows Update for Business. So whichever way you go, have a look at the types of host pools that you're deploying. Are you deploying Windows 10 single session versus Windows 10 multi-session? And you have a choice as well. So I might be deploying both single session and multi-session. I could choose to manage single session VMs with just Intune by itself, but you leveraging the Config Manager agent on those VMs, and look at Windows 10 multi-session because it's sort of more of a non-persistent type desktop from a user point of view. I can continue to manage that with Configuration Manager. I have choice. I can have my cake and I can eat it as well. All right, so let's talk applications and updates. Windows Virtual Desktop is, of course, just a Windows desktop. It's running applications. Users are logging into that virtual machine and running their apps. They're running perhaps a wide range of applications, off-the-shelf apps, line of business applications, but they're also running those applications on top of a Windows operating system which also needs to be kept up to date. Applications are, of course, a key component to keep up to date inside that desktop. So we might update applications from a performance and feature perspective, but we may also need to keep applications up to date from a security point of view. Older applications are invariably going to have weaknesses and vulnerabilities in them, and we need to be able to address that. One of the great tools I think that Microsoft provides is Microsoft Defender for Endpoint. Now, of course, Defender for Endpoint isn't available for everyone. You need effectively Microsoft 365 E5 licensing, but it gives you this type of insight into what's going on in the desktop. Now, this is a real desktop in our environment that I'm showing you here. Hopefully I have hidden all the identifying information. But you can see in this report that this particular device has a number of applications on it that are out of date. They have a number of weaknesses against them. So take a look at there at 7-zip as an example. Adobe Flash Player is still on there. There's some older versions of Apple QuickTime, Receiver, Git, Google Chrome, Office, and so on. So what Defender for Endpoint provides me, whether I'm looking at this from a perspective of a physical PC or a virtual machine running under Windows Virtual Desktop, I can roll both of those into Defender for Endpoint and get these types of insights and recommendations on what applications are out of date, what is the risk in leaving that application out of date and not upgrading it. So if you ever need some justification to upgrading an application, then take a look at these reports that you'll find inside Defender for Endpoint. It also provides recommendations to secure the desktop. So here we've got a number of applications, of course, that are out of date, but it might go as far as pointing out a specific configuration in application to keep that secure. So the Microsoft 365 apps is a good one. I can deploy the Microsoft 365 apps inside Windows Virtual Desktop. I might deploy it to a Windows 10 single session VM and leave updates on to have it automatically update. But the user can go into the application and they can disable updates inside that application. And Defender for Endpoint will surface this up and show you that you should be enabling a policy to prevent the user from disabling updates. I've also talked about desktop analytics. So coming back to an application point of view from desktop analytics, I talked about application compatibility status and so on, and I'm planning upgrades. Desktop analytics, another tool to have in my kit bag to make sure that I'm planning application upgrades and operating system upgrades and ensuring that I'm not going to affect access to applications and maybe actually test that those applications are compatible before I go ahead and do upgrades. The other one then we can look at is like, okay, how do we keep applications up to date? So here we've got Patch My PC. Now, this is not an ad for Patch My PC. There are some other tools out there like Liquid, for example, but I'm using Patch My PC in my environment, and it's actually, I think, a pretty cool solution. So let's go have a look at a real environment. Here in Patch My PC, I can integrate both Configuration Manager apps and Intune applications. So whether I'm delivering applications via the Config Manager agent or via the Intune agent, what I can do with a tool such as Patch My PC is I can automatically package applications and keep those applications up to date by delivering new versions of the app. So here, for example, if I go and have a look at Acrobat Reader, I can set up some options for configuration of that app. It probably drops a desktop shortcut on the desktop, or a shortcut on the desktop which I want to get rid of, so I can go and tell it to delete that, or I can go and modify the install command lines. So in particular, maybe I'm deploying to Windows 10 multi-session and I want to ensure that the Adobe Reader automatic update is turned off, because if I'm running in a multi-session environment, I don't want this suddenly updating applications in one user session and affecting other user sessions. I want to have a little bit more control around application updates, so I can go and do that. So a tool such as this enables me to automatically package off-the-shelf applications, automatically package new versions of those applications, and push them into either Configuration Manager or an Intune. The other great thing that it does is that it will manage assignments. So let's say, for example, I go and package Adobe Reader and I assign it to my Windows Virtual Desktop VMs. New version comes out. This tool will be able to remove those assignments from the old package, put those same assignments against the new version of the package. We can schedule when that application is going to be installed into the virtual desktop, and then that application remains up to date. And I can run this on a schedule, so I don't have to worry about manually going in and packaging these and keeping that desktop up to date. Okay, so what about updates, operating system updates? So I'm a big fan of simplicity. For Tools such as WSUS managed through Config Manager. There's a lot of other people smarter than me who do this day in, day out, and are able to manage machines effectively through WSUS. However, I'm a big fan of the simplicity of doing or managing updates through Intune directly. So I can use Intune to manage updates via Windows Update for Business, and here I can deploy update rings. So I may have update rings for different types of host pools. Maybe I'm separating single session and multi-session per host pool, regional host pools, or even host pools based on different workloads. So here I can go and integrate them into Windows Update for Business and create things like active hours, so I can create maintenance windows and manage when updates are going to be deployed and so on. Additionally, what I can do through here is I can enable feature updates. Now, Microsoft recently announced that they're supporting in-place upgrades for Windows Virtual Desktop VMs. So now I can leverage, I guess in a supported manner, feature updates via Intune to Windows Virtual Desktop machines. Pretty straightforward for Windows 10 single session, particularly users log onto those desktops. They get access to the same desktop every time that they connect to a session. That's pretty much the same as a physical PC. Multi-session might be a little bit different. Maybe I want to have the types of applications I'm delivering to multi-session may sometimes be a little bit different between single session and multi-session. So I need to be a little bit more careful with how I'd manage upgrades for those Windows 10 multi-session VMs. But again, I can do the same thing. I can create update rings which manage feature updates and when those updates are deployed, when maintenance windows are, and then I can use update rings to determine when a virtual machine is going to upgrade to a specific version of Windows 10. Now, one of the questions I think, an important question to cover too, when we talk about virtual machines running on Azure, is that Azure provides a couple of key features. One of those is update management, and closely tied to those are inventory and change tracking. So update management is again, it leverages Windows Update for Business, and I can provision this at an Azure level, so I can automate enrollment of machines and enrolling them into update management. I can schedule when updates are going to deploy, but the key thing here is that update management inside Azure just manages the operating system, just manages quality updates inside the operating system. You would have to manage in-place upgrades separately, and update management doesn't manage applications. So you're still going to have to look at what you can do with Windows Virtual Desktop to enroll desktops in Config Manager or Intune, or both, leveraging co-management. So I can, through the same interface, I can manage updates for both the operating system as well as the applications, which is an absolutely important piece of maintaining Windows Virtual Desktop's VMs. Okay, let's take a look at attack surface reduction. So I'm doing this through the Intune console, and there's a number of features inside attack surface reduction that we can jump into. And some of these aren't necessarily applicable to Windows Virtual Desktop, but I think it's worth discussing anyway. So there's a few here. Application control I'm going to talk about in a second. Features such as exploit protection, device control, and application guard require virtualization features on the device. So these attack surface reduction policies aren't necessarily going to be applicable to Windows Virtual Desktop today. So one of these would be application guard, where I can run now. I can run the browser and the Microsoft 365 applications inside a virtualized container, if you like, where I'm opening attachments from untrusted locations, or I want to browse untrusted sites. And on a Windows 10 physical PC, I can use Application Guard to run the Edge browser and the Microsoft 365 apps in a virtualization layer that protects the device from those applications which may be compromised. Microsoft is providing features such as UEFI and virtual TPM and secure boot. They provide UEFI today, virtual TPM and secure boot are features that are coming to Azure virtual machines. I think they're in preview at the moment, maybe private preview, but I have seen where that is actually up and coming. So things like application guard and device guard, we might be able to use, or device control, I should say, we might be able to use with Windows Virtual Desktop in the future. And I think the application guard in particular is a key feature to ensure that we can keep those virtual machines secure. The easy one though, and this is really one worth having a look at, is the attack surface reduction rule sets. Now, I will say, don't go ahead and just create a policy that will implement attack surface reduction rules and just set them all to enable or block mode, because we may prevent a certain application from working, so it's well worth testing. But these policies in here, so where I can enable or block specific features of an application or Windows operating system itself, can help to prevent attacks that maybe drive-by attacks that come through the browser or through Outlook or something like that. Maybe even Adobe Reader that we've got here. I can harden those applications in the operating system to make that virtual machine less vulnerable to attack. Also in the attack surface reduction bucket, I'm going to put in security baselines. So these are security baselines are published by Microsoft on a fairly regular basis, particularly when new versions of Windows 10 come out, and those new versions may include new features that may necessitate additional security baselines or changes to the security baseline, but also for Microsoft Edge. So this one I think is really good. Every Microsoft 365 customer should be deploying Edge. They should be, in my view, migrating away from other browsers to Microsoft Edge, because I can sign into the Edge browser with my Microsoft 365 account. That enables synchronization of things like passwords and bookmarks and history and so on. And I can also use Endpoint Manager then to manage Edge. So the policy tools built into Intune, for example, support Edge, where I go and if I need to support another browser through Intune, I'm going to have to import and create custom rule sets to be able to do that. So the Edge baseline is a pretty straightforward component to actually go and deploy, and there's one in here that I wanted to highlight in particular, and that is extensions. So the baseline will by default disable extensions, which means I sign into the browser, I want to go and add an extension. I could go to the Edge extension store. I can browse the store, but I'm not going to be able to import those extensions into the browser. Starting at a disabled state for those extensions is a good place to start, but it potentially means additional effort on the IT administrator. So there's going to have to be some level of user communication to say, well, here's Edge browser, here's where the extensions, and you can go and add these extensions. Maybe the administrator's already assigned a set of specific, create an allow list for a specific set of approved extensions and enable those. But where users need further extensions, they're going to have to go through a process to request access to those. So this is key to keeping the browser secure. Extensions that may have been compromised somehow, if we start in a block state, they're not going to be able to, users aren't going to be able to import those or enable those extensions inside the browser. Okay, so that's attack surface reduction, and let's delve a little bit deeper into application control. So there are two features for that Microsoft provides for application allow list and block lists. That is Microsoft Application Control, and one that probably most people are familiar with is Microsoft App Locker. So with application control, I can go and deploy, I can pretty easily, in fact, go and enable an application control policy to lock that machine down. Now that might be a Windows Virtual Desktop virtual machine. I've enabled application control in there because I have a known set of applications that are running inside that virtual machine. And to keep that virtual machine secure, I want to ensure that only those applications can be executed. Users are logging into that virtual desktop. They've got a browser. They can probably browse the internet. They can probably download applications and executables off the internet, or they might be targeted by some sort of drive-by attack through the browser or their mail client. and application control can prevent execution of those executables inside that virtual desktop. Controlling application execution through an allow list or a block list is one of the best things that you can do to ensure that that environment remains secure. Now, that's a little easier said than done. One of the first things that we might do in a VDI environment is ensuring that users don't have administrator access. These days, most applications will work without admin rights, and that's the sort of defense in-depth approach that we can take. I can take admin rights away from them. I can ensure that that virtual machine is enrolled into Endpoint Manager for operating system and application updates. But if I take it a step further, I can enable an allow list or a block list, explicitly allowing specific applications to run in that virtual machine, and I can ensure that unauthorized code cannot execute. Now, while application control policies are available in both Configuration Manager and here in Intune, there are some considerations for Microsoft Defender Application Control. The first of those is it requires UEFI. By default, anyone deploying Windows virtual desktops are most likely deploying on Gen 1 Azure VMs. To support UEFI on Azure, I need Gen 2 virtual machines. So I'm going to have to deploy, of course, on Gen 2 virtual machines, but that is going to require me to create a custom ARM template to actually go and deploy virtual machines on Gen 2 VMs for Windows Virtual Desktop. Now, Defender Application Control has a lot of benefits. It's pretty easy to enable, and it enables by default operating system components and signed drivers to work. Drivers probably not so much of a challenge inside WVD, but because these components are signed, they will just automatically run without having to create any additional rule sets for them. Store-based applications will run. Inside WVD, I've probably got a little bit of a different consideration for Windows 10 single session versus multi-session, where I might be running store applications on single session. I may not necessarily be running them on multi-session, but applications coming from the store will be allowed execution by Defender Application Control. The other key one then are applications deployed by the Config Manager client. So I have an application, I need to deploy it to a target machine. If it's deployed from the Config Manager client, then it will be trusted for execution by Defender Application Control without having to do any additional configuration or create an allow list specific for that application. Additionally, then updates from Windows Update for Business or WSUS, of course, so I need to patch up the operating system, keep it up to date. I don't have to do anything additional to get that to run through application control. Finally, then, Defender Application Control can leverage the Microsoft Intelligent Security Graph. So Microsoft, through the Intelligent Security Graph, sees all sorts of information around good and bad code that runs on Windows desktops. So the power of providing diagnostic or metrics back through Microsoft enables Microsoft to sort of pull this information around what is good and bad, or good code and malicious code, and can, based on the code that it's seen running around the place, can automatically block bad stuff or even allow worthwhile applications from running. And you've probably seen this through the Smart Screen feature. If I download an executable, maybe it's something that is not common and it can be blocked by Smart Screen. Okay, so the other method for enabling an allow list or block list inside a virtual machine is with AppLocker. AppLocker has been around since Windows 7, so it's probably a known quantity for a number of organizations. And in some respects, I think it's a little bit simpler to implement in regards to application control. So with application control, I mentioned that we need UEFI to deploy. So most Windows virtual desktop environments probably aren't leveraging Gen 2 VMs at the moment. So if they're not leveraging Gen 2 VMs, they need to have a look at something like AppLocker to be able to implement this allow list or block list. So AppLocker by itself, you can configure through a group policy, but it's you need a way, I think, to maintain that configuration. It's not just a one-time, let's go and create our allow list and implement that and push that out via group policy, Intune, or configuration manager, whatever the case may be. we need to maintain that configuration and update it as operating system versions change and application requirements change, and maybe even change between, say, different host pools or single session versus multi-session, because I might have different application requirements. Fortunately, there's a team in Microsoft that provide this tool, which you can find up on GitHub, so github.com/Microsoft/AaronLocker. And effectively what this is a set of PowerShell scripts that you can use to manage AppLocker configurations. So it has, for example, and this one I think is pretty key, a number of inputs. So I can create paths. I might have applications in non-standard paths that I need to account for. Or I might have applications that are not signed. I can't allow them to execute just by certificate. I need to hash those, create the hash for those executables and allow those to execute. So one of those configuration inputs here, if I go to get exe files to deny list, the great thing about what's provided here in AaronLocker is it includes by default a set of executables that are built into the operating system that you should be denying execution for. So anyone familiar with AppLocker already is probably familiar with managing AppLocker through group policy. I can go in and create a group policy object. I can create a default set of rules that allow execution from, say, C Windows or C program files. What it doesn't account for is these types of executables that are built into the operating system that you should be disallowing. So that's built into AaronLocker. AaronLocker, as I said, is basically a set of PowerShell scripts, a set of rules that are managed through PowerShell, and because of that, I can effectively manage that configuration through code. So I've got here another repository that I've also got sitting up in GitHub, and I'm using this as a method to manage the AppLocker configuration with AaronLocker, no relation to myself, but manage that AppLocker configuration with code. So that's customized specifically for my environment. And because it's in a repository like this, then I can have multiple people contributing to this AppLocker configuration. I can track changes. I can see what's happening between different configurations. So instead of relying on, say, a group policy object or relying on an Intune configuration that's being used to deliver the AppLocker configuration, I can manage that configuration as code and track changes. So from an Intune point of view, we can actually deliver that AppLocker configuration, and we need to actually do this through a custom policy. So what this means is creating that the AppLocker configuration, which at the end of the day it outputs an XML file, and I can use a custom OMA URI set of policies to deliver those. So here I've got a policy delivered via Intune that's delivering a configuration for AppLocker in audit mode, because I want to start with audit mode so I know what's going on inside my environment. I can test it and update the configuration to account for applications that might be blocked if I put it into enforce mode. And I'm doing that through this policy here. And what that looks like is pretty straightforward. If I can open this up, and I'm just pushing out a specific OMA URI policy, and the value of that is an XML file. Now that XML file I'm maintaining through code that I've got sitting here. So I've got a configuration sitting inside my GitHub repository, and if I go and generate that through AaronLocker, then it would look a little something like this. So because AaronLocker runs as a set of PowerShell scripts, I'll run this inside my gold image or some type of machine or VM that I maintain as representative of virtual machines and applications that are in my environment. So AaronLocker's got this create policy script. Great thing about this is it will generate an AppLocker configuration as well as an application control configuration. So highly recommend that you have a look at the AaronLocker toolset. So run that tool, it runs against my machine. You can see down here at the bottom of the screenshot, it's actually running against or scanning OneDrive and Teams. Now these are applications that get updated quite a bit. So maybe I need to update my rule sets based on these applications. Hopefully they're well signed. something like that comes from Microsoft, I want to ensure that it's signed, or hope that it's signed with a code signing certificate from Microsoft, so I don't have to do any further action. But if there happens to be something inside that application that isn't signed, then I can scan it with this and I can generate hash file data for that. And then at the end of it, I get a configuration that I can then go and import. I can cut up and push into my my app locker configuration via Intune, or I can go and deliver that as an application control configuration, depending on my approach to allow list and block list, and how I'm if I'm using app locker or application control, and go and manage that configuration. Okay, so with that, it's time for bonus round. So now that we have Windows Virtual Desktop managed with Microsoft Endpoint Manager, why not manage endpoints with Endpoint Manager as well? In this particular case, let's convert some older Windows 10 machines into dedicated WVD thin clients. So the way we would do this is through Windows Autopilot. Now, I'm going to take these devices and I'm going to apply a self-deploying Azure AD joined Windows Autopilot profile to these devices. What that means is that I can take a device, I can plug it into a network connection, and once it gets access to the internet, Windows Autopilot will take over and provision that device completely hands-off. No user has to be in front of it until it's time to actually sign into the device and launch the remote desktop client. So I can turn that Windows 10 device through Intune here into a kiosk-based device effectively. And that kiosk-based device can only run one thing, the remote desktop client. So I've configured here that it should run the remote desktop client, and that's what is available to the user on the start menu. However, it will also auto-launch. So once I sign in, the remote desktop client will launch automatically, and the user can get access to their Windows Virtual Desktops and applications. So let's see what that looks like in action. Okay, let's see what the user experience of this looks like. And I think this is pretty cool. So what I'm actually using here is a YubiKey. I'm going to sign in with the security key. And as you can see here in the video, the user can sign in, put in their PIN, not have to enter their username or password to sign into the device. So I've plugged it in, put in my PIN, touch the key, the device is signed in. I've come up to the Windows Remote Desktop client, click subscribe. I'm already signed into the device. So single sign on. And once it looks at or requests a feed, I get access to my applications and desktops. Done. Okay, with that, I want to thank you so much for attending this session. If you haven't heard of me before, my name is Aaron Parker. I'm a CTP, I have been since 2012. I was previously a Microsoft MVP. I am the Principal Modern Workplace Architect at Incentra. Incentra is a channel services organization based here in Australia, the Philippines, UK, and the US. And if you have any questions, please hit me up on Twitter @StealthPuppy. Thank you.